Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics Classes. I am Sudhir MK. I am going to discuss trigonometric formulas in this class. Please subscribe the channel for more video notification. Now first we see what is circular measure. Here angles are measured in radians. In circular measure, angles are measured in radian. Now what is 1 radian? So 1 radian is the angle subtended at the center of the circle by an arc of length equal to radius of the circle, and it is denoted by 1c. So we consider a circle of radius r. If we consider an arc of length r, then the angle subtended by that arc at the center. So this angle is equal to 1 radian. So this angle equal to 1 radian. That is 1 radian is the angle subtended by an arc of length equal to radius of the circle. So this arc length should be equal to radius of the circle. So then angle at the center will be 1 radian and it is denoted by 1c. So next we see the relation between radian and degree. So that is 1 radian equal to 57 degree, 16 minutes and 22 seconds. That is 1 radian equal to 57 degree, 16 minutes and 22 seconds. So same type 1 degree equal to 0.01745 radians. So 1 degree equal to 0.01745 radians. So next we study how to convert degree to radian and radian to degree. Suppose if it is given x degree, so we have to convert into radian. So x degree equal to x into pi by 180 radian. To convert degree to radian, you have to multiply that angle by pi by 180. We take one example, that is 60 degree. 60 degree can be written as 60 into pi by 180. You have to multiply 60 by pi by 180. So that is here 61s are 63s are, so we get pi by 3 radian. So therefore 60 degree can be written as pi by 3 radian. That is to convert degree to radian, you have to multiply by pi by 180. So next we consider how to convert radian to degree. So it is x radian. X radian is x into 180 by pi degrees. That is if you want to convert radian to degree, you have to multiply by 180 by pi. So we consider one example, pi by 12 radian. So pi by 12 radian equal to pi by 12 into 180 by pi degrees. You have to multiply by 180 by pi. So here pi cancel. Here it is 12 ones are and 12 15s are. So 12 15s are 180. So therefore we get 15 degrees. So pi by 12 radian equal to 15 degree. So pi by 12 radian equal to 15 degree. So next formula, length of an arc, L equal to r theta. So if you want to find length of an arc in a circle of radius r and central angle is theta, then L equal to r theta. So this is length of an arc formula. And area of sector, A equal to half r square theta. So sector means area bounded by 2 radii and this arc. So this portion is sector. So sector of the circle. So if you want to find this area, directly we can use formula A equal to half r square theta. Here important, theta is always measured in radians. So theta should be in radians. Suppose if they are given in degrees, you have to convert into radian and you have to apply these formulas. So L equal to r theta, that is length of this arc, and area equal to half r square theta. So area of this region. So area of sector A equal to half r square theta, where theta measured in radians. So next we consider one right angle triangle. So we know that hypotenuse is the longest side or it is opposite to 90 degree. So this angle is 90 degree, that is angle B is 90 degree. Opposite to 90 degree, that is side AC, it is hypotenuse. And we consider one angle is theta. So consider angle C equal to theta. Then the side opposite to this theta, that is AB, it is called as opposite side. And the other side, that is nearest to theta, it is called as adjacent side. So here side opposite to 90 degree, it is always hypotenuse. Opposite to theta, it is opposite side. And the other side, it is called as adjacent side. This is in right angle triangle. So this is in right angle triangle. Using these 3 sides, we define 6 trigonometric ratios. So first we define sine theta as opposite by hypotenuse, and cosecant theta is hypotenuse by opposite. So then it is cos theta. Cos theta is adjacent side by hypotenuse, and secant theta is hypotenuse by adjacent, and tan theta is opposite by adjacent side, and cot theta is adjacent by opposite side. So these are 6 trigonometric ratios. So sine theta is opposite by hypotenuse, and cosecant theta is hypotenuse by opposite. So that is hypotenuse by opposite is cosecant theta. So cos theta is adjacent side by hypotenuse, and secant theta is hypotenuse by adjacent side, and tan theta is opposite by adjacent side, and cot theta is adjacent side by opposite side. So these are 6 trigonometric ratios. So sine theta, cosecant theta, cos theta, secant theta, tan theta, and cot theta. So then we have reciprocal relation, sine theta equal to 1 by cosecant theta, and cosecant theta can be written as 1 by sine theta. Using this, we can write sine theta into cosecant theta is 1. So if we take cosecant theta other side, so we get sine theta into cosecant theta is 1. So this is reciprocal relation, that is sine theta can be written as 1 by cosecant theta and cosecant theta can be written as 1 by sine theta. Therefore, sine theta into cosecant theta is always equal to 1. Now same type, cos theta equal to 1 by secant theta or secant theta equal to 1 by cos theta. When we cross multiply, we get cos theta into secant theta equal to 1. So cos theta equal to 1 by secant theta or secant theta equal to 1 by cos theta. So this implies cos theta into secant theta equal to 1. So next relation, it is tan theta equal to 1 by cot theta equal to 1 by tan theta. So we can multiply this. So when we multiply this, we get tan theta into cot theta is 1. So tan theta equal to 1 by cot theta equal to 1 by tan theta. So therefore we can write tan theta into cot theta equal to 1. So these are our reciprocal relations. So next we find relation between sin theta, cos theta and tan theta. So sin theta by cos theta is tan theta. Therefore tan theta is sin theta by cos theta. Same type, cos theta by sin theta is cot theta. So therefore cot theta is cos theta by sin theta. So tan theta is sin theta by cos theta and cot theta is cos theta by sin theta. So next it is identities. So we have three important identities. So first one, it is sin square theta plus cos square theta is 1. So sin square theta plus cos square theta is 1. So from this we can write 1 minus sin square theta. When we take sin square theta to this side, we get 1 minus sin square theta equal to cos square theta. So same type, when we take cos square theta to this side, we get 1 minus cos square theta equal to sin square theta. So these are relations between sin theta, cos theta. So that is sin square theta plus cos square theta is 1 and 1 minus sin square theta is cos square theta and 1 minus cos square theta is sin square theta. So next identity, so that is 1 plus tan square theta is secant square theta. 1 plus tan square theta equal to secant square theta. Or if we take 1 to this side, we get secant square theta minus 1. So secant square theta minus 1 is tan square theta. Or if we take tan square theta to this side, we get secant square theta minus tan square theta. Secant square theta minus tan square theta equal to 1. So that is 1 plus tan square theta is secant square theta. Secant square theta minus 1 equal to tan square theta and secant square theta minus tan square theta is 1. And next identity, 1 plus cot square theta. 1 plus cot square theta is cosecant square theta. So if we take 1 to this side, we get cosecant square theta minus 1. So cosecant square theta minus 1 is cot square theta. When we take cot square theta to this side, we get cosecant square theta minus cot square theta equal to 1. So therefore, 1 plus cot square theta equal to cosecant square theta. That implies cosecant square theta minus 1 equal to cot square theta and cosecant square theta minus cot square theta equal to 1. So these are three important identities. So next we consider the identity secant square theta minus tan square theta equal to 1. So here we can factorize this using formula a square minus b square is a plus b into a minus b. So we can write secant square theta minus tan square theta as secant theta plus tan theta into secant theta minus tan theta equal to 1. So we take any one term to other side. So if we take secant theta minus tan theta to other side, we get secant theta plus tan theta equal to 1 by secant theta minus tan theta. Secant theta plus tan theta equal to 1 by secant theta minus tan theta. So here remember this 1 by secant theta minus tan theta. Suppose if you want to take this number to numerator, so directly we can write secant theta plus tan theta or 1 by secant theta plus tan theta. 1 by secant theta plus tan theta can be written as secant theta minus tan theta. So this is very important relation. 1 by secant theta minus tan theta is secant theta plus tan theta. So same type, 1 by secant theta plus tan theta equal to secant theta minus tan theta. So these are two important relation. So next one, cosecant square theta minus cot square theta equal to 1. So next we have identity cosecant square theta minus cot square theta equal to 1. Here also we factorize this. We can write a square minus b square as a plus b into a minus b. So we can write cosecant theta plus cot theta into cosecant theta minus cot theta equal to 1. If we take cosecant theta minus cot theta to denominator, we get cosecant theta plus cot theta equal to 1 by cosecant theta minus cot theta. So therefore 1 by cosecant theta minus cot theta can be written as cosecant theta plus cot theta. So same type, if we get 1 by cosecant theta plus cot theta, so we can write it as cosecant theta minus cot theta. So it is 1 by cosecant theta plus cot theta equal to cosecant theta minus cot theta and 1 by cosecant theta minus cot theta equal to cosecant theta plus cot theta. So next we study trigonometric ratios of standard angles. So here standard angles are 0 degree, 15 degree, 13 degree, 45 degree, 60 degree, 75 degree, 90 degree, 180 degree and 270 degree. We can express this in radian. So 15 degrees, pi by 12, 30 degrees, pi by 6, 45 degrees, pi by 4, 60 degrees, pi by 3, 75 degrees, pi by 12, 90 degrees, pi by 2, 180 degrees, pi and 270 degrees, 3 pi by 2. And 360 degree and 360 degree same as 2 pi, so it is values of 0 degree only. So here sine 0 is 0 and sine 15 is root 3 minus 1 by 2 root 2 and sine 30 degrees 1 by 2 and sine 45 is 1 by root 2 and sine 60 is root 3 by 2 and sine 75 degrees root 3 plus 1 by 2 root 2. So sine 75 degrees root 3 plus 1 by 2 root 2 and sine 90 is 1 and sine 180 is 0 and sine 270 is minus 1. It is sine values. So next it is cos values. So cos 0 is 1 and cos 15 degree. Cos 15 degrees root 3 plus 1 by 2 root 2 and cos 30 degrees root 3 by 2 and cos 45 is 1 by root 2 and cos 60 is 1 by 2 and cos 75 is root 3 minus 1 by 2 root 2 and cos 90 is 0. So cos 90 is 0, cos 180 is minus 1 and cos 270 is again 0. And if you want to find cos 360 is 1. So that is same as cos 0. And sin 360 is 0, which is same as sin 0. And tan 0 is 0. Tan 15 is 2 minus root 3. Tan 30 degrees 1 by root 3. Tan 45 degrees 1. And tan 60 is root 3. Tan 75 is 2 plus root 3. And tan 90 is infinity, or it is not defined. And tan 180 is 0. And tan 270 is minus infinity. Tan 270 is minus infinity and tan 360 degrees same as tan 0, it is 0 only. So these are trigonometric ratios of standard angles. So here we are taking angles 0 degree, 15 degree, 30, 45, 60, 75, 90, 180 and 270 only. So next we consider some other values. So it is sine 18 degree is same as cos 72 degree. It is root 5 minus 1 by 4. So sine 18 degree is same as cos 72 degree and values of sine 18 and cos 72 degree is root 5 minus 1 by 4. So next it is sine 54 degree. So sine 54 degree equal to cos 36 degree equal to root 5 plus 1 divided by 4. So sine 54 degree equal to cos 36 degree equal to root 5 plus 1 divided by 4. So same type tan 22 and half. So tan 22 and half equal to root 2 minus 1. So tan 22 and half degree equal to root 2 minus 1. So these are some important values for competitive exams. So next we study domain and range of trigonometric ratios. So first we consider sine theta. So here domain is theta value. So here we can substitute any real value for theta. So therefore domain is r. For sine theta domain is r and range. So highest value for sine theta is 1 and least value is minus 1. So therefore range for sine theta is minus 1 to 1. And for cos theta also. So here theta value is any real number and highest value for cos theta is 1. Least value is minus 1. Therefore range for cos theta is minus 1 to 1. So here both are closed brackets. So here minus 1 and 1 are included. So next tan theta. So we know that tan theta is not defined at 90 degree and 270 degree. So it is 90 degree means odd multiples of 90 degree. Odd number means 2n plus 1 form. So therefore tan theta is not defined for odd multiples of pi by 2. So here domain is r minus 2n plus 1 pi by 2. That is r minus odd multiples of pi by 2. And range. So here highest value is infinity, least value is minus infinity. So therefore we get all the real numbers. Therefore range is set of real numbers. So next for cosecant theta. So for cosecant theta domain is r minus n pi. So when sin theta is 0, so cosecant theta is not defined. So sin theta is 0 for 0 degree, 180 degree or it is 360 degree like that. So it is multiples of pi. So it is 1 pi, 2 pi, 3 pi, 4 pi. For all that angles sin theta is 0. So therefore cosecant theta is not defined at n pi. Therefore domain for cosecant theta is r minus n pi. And range for cosecant theta we get all the values more than or equal to 1 and less than or equal to minus 1. So all the values should be more than or equal to 1 or less than or equal to minus 1, or we can write like this. It is mod x greater than or equal to 1. So this is range for cosecant theta. So all the values should be more than or equal to 1 or less than or equal to minus 1, or we can write it as mod x greater than or equal to 1, or it is r minus minus 1 to 1. So here minus 1 and 1 included. So that is cosecant theta may be 1 or cosecant theta may be minus 1 also. Next, same type for secant theta. So secant theta is not defined when cos theta is 0. So cos theta is 0 for 90 degree, 270 degree. That is again odd multiples of 90 degree. So therefore secant theta is not defined at that values. So therefore we can take domain of secant theta is r minus 2n plus 1 pi by 2. So that is real numbers minus odd multiples of pi by 2. So here domain is r minus 2n plus 1 pi by 2. So this is domain for secant theta. And for secant theta, range is same as cosecant theta only. So here all the values more than or equal to 1 and less than or equal to minus 1. And here also we can write mod x greater than or equal to 1. So that is all the values more than or equal to 1 and less than or equal to minus 1. We will not get any values in between minus 1 and 1. So next it is cot theta. So cot theta is not defined when tan theta is 0. So tan 0 is 0, tan 180 is 0, tan 360 is 0. That is all the multiples of pi. So it is 0 pi, 1 pi, 2 pi, 3 pi. In all that angles, tan is 0. Therefore, cot is not defined in that angles. So you have to take domain of cot theta is r minus n pi. So r minus n pi, it is domain of cot theta, and ranges, it is set of real numbers. Highest value it is plus infinity and least value is minus infinity. So therefore here we get all the real numbers. So therefore range is set of reals. So this is domain and range for trigonometric ratios. So next we see graph of trigonometric function. So first one it is graph of sine x. So we see graph of y equal to sine x. So we know that sine 0 is 0, sine 90 is 1 and sine 180 is 0. Also sine minus 90, sine minus 90 is minus 1 and sine of minus 180 is 0. When we draw all these points, we get graph like this. So this is graph of y equal to sine x. So here highest value is 1 and least value is minus 1. Therefore range for sine x is minus 1 to 1. Therefore range for sine x is minus 1 to 1. So highest value is 1 and least value is minus 1. So next we see graph of y equal to cos x. So we know that cos 0 is 1 and cos 90 is 0 and cos 180 is minus 1 and cos 270 is again 0 and cos of minus 90 is 0 and cos of minus 180 is minus 1 and cos of minus 270 is 0. So when we draw all these points, we get graph like this. So this is graph of y equal to cos x. So here also highest value is 1 and least value is minus 1. Therefore range for cos x is minus 1 to 1. So highest value is 1 and least value is minus 1. So next it is graph of y equal to tan x. So here to draw the graph of y equal to tan x, we draw dotted lines like this when tan x is not defined. So we know that tan is not defined at 90 degree, 270 degree, minus 90 degree and at minus 270 degree. We draw dotted line like this. And we know that tan 0 is 0 and tan 45 degrees 1 and tan 90 is infinite. And we know that tan is positive in first quadrant and negative in fourth quadrant. When we draw the graph, we get graph like this. So this is graph of y equal to tan x. So here in first quadrant, tan is positive. In second quadrant, that is from 90 to 180 degree, tan is negative. And in third quadrant, it is 180 to 270 degree, tan is positive. And in fourth quadrant, tan is negative. So this is graph of y equal to tan x. So next it is graph of y equal to cot x. So graph of y equal to cot x, it is again same as tan x graph. Cot x is not defined when tan x is 0. So that is tan 0 is 0. So therefore cot x is not defined at 0 degree and at 180 degree and at minus 180 degree. So we draw dotted line like this at 0 degree, 180 degree and minus 180 degree. At these points cot x is not defined. And we know that tan 90 is infinite and cot 90 is 0. At this point cot is 0. Same type cot of minus 90 is also 0. And cot x is positive in first quadrant and negative in second quadrant. And again positive in third quadrant and negative in fourth quadrant. So therefore graph of y equal to cot x is like this. So this is graph of y equal to cot x. So next we see graph of y equal to cosecant x. So we know that when sine is 0, cosecant x is not defined. So sine is 0 at 0 degree, at 180 degree, at 360 degree and minus 180 degree and minus 360 degree. At these points cosecant x is not defined. So therefore we draw dotted line like this. So we know that sine 90 is 1. So cosecant 90 is also 1. And sine 270 is minus 1. So therefore cosecant 270 is also minus 1. and sine minus 90 is minus 1. So cosecant minus 90 is minus 1 and sine minus 270 is and sine minus 270 is plus 1. So therefore cosecant minus 270 is plus 1. So we get these points and we get graph of y equal to cosecant x like this. So here all the values are more than 1 and all the values are less than minus 1. So therefore all the values of y equal to cosecant x is more than 1 and less than minus 1 and graph of y equal to cosecant x is like this. So next we see graph of y equal to secant x. So secant x is not defined when cos x is 0. So cos is 0 at 90 degree, at 270 degree, at minus 90 degree and minus 270 degree. At this point cos x is 0. So secant x is not defined when cos x is 0. At this point secant x is not defined. So we draw dotted line like this. And we know that cos 0 is 1. So therefore secant 0 is also 1. And cos 180 degree. Cos 180 degree is minus 1. So secant 180 degree is also minus 1. And cos of minus 180 degree. Cos of 180 degree is minus 1. And cos of 360 degree. And cos of 360 degree is 1. And cos of minus 360 degree is also 1. So therefore we get graph of y equal to secant x like this. So here also we get all the values more than 1 and less than minus 1. So therefore graph of y equal to secant x is like this. So this is graph of y equal to secant x. So next we know that sine of n pi equal to 0. That is n pi means 1 pi, 2 pi, 3 pi like that. So that is all multiples of pi 180 degree. So sine 0 is 0, sine 180 is 0, sine 360 degree is 0. So that is all multiples of pi. So 1 pi, 2 pi, 3 pi, 4 pi like this. So all multiples of pi. So sine of n pi equal to 0. So next it is tan of n pi is 0. So same type sine n pi equal to 0. Tan of n pi is also 0. So next cos of even multiples of pi equal to 1. So we know that cos 0 pi. So that is cos 0. So this angle. So cos 0 is 1. And cos 180 is minus 1. Cos of 0 degree. Cos of 0 degree is 1. It can be written as 0 pi. So cos of 0 pi is 1. And cos of 1 pi. So that is cos of pi is minus 1. So then cos of 2 pi. So cos of 2 pi is cos of 360 degree. Again it is 1. So, and cos of 3 pi. So cos of 3 pi is minus 1. And cos of 4 pi is 1. And cos of 5 pi is minus 1. So like this we know that cos of even multiples of pi is 1. And cos of odd multiples of pi is minus 1. That is cos of 0 pi, 2 pi, 4 pi all are equivalent to 0 degree. Therefore cos of even multiples of pi is 1 and cos of odd multiples that is 1 pi, 3 pi, 5 pi which are equivalent to 180 degree all are equal to minus 1. So then cos of odd multiples of pi by 2 is always equal to 0. That is cos of 1 into 90. So that is cos 90. So cos 90 is 0 and cos of 3 into 90. So 3 into 90 is 270. It is 3 into 90 degree. So 3 into 90 is 270. At this value is also cos is 0. And cos of 5 into 90 which is same as 90 degree. And 7 into 90 degree. At all these angles cos is 0. That is cos of odd multiples of pi by 2 is 0. But it is not even multiples. If you get 2 into pi by 2 which is same as pi, at this angle cos is not 0. So that is cos pi is not 0. So cos pi is minus 1. That is only odd multiples. So odd multiples of pi by 2. So cos of odd multiples of pi by 2 is 0. That is cos of 2n plus 1 pi by 2. So it is cos of 2n plus 1 means odd numbers into pi by 2 equal to 0. So next we say sin theta equal to cos of 90 minus theta. So this is one more relation between sin theta and cos theta. Cos 90 minus theta is sin theta. So same type sin 90 minus theta is cos theta or cos theta can be written as sin 90 minus theta. And tan theta can be written as cot 90 minus theta. And tan 90 minus theta is cot theta. So same type cosecant theta can be written as secant 90 minus theta and secant theta can be written as cosecant 90 minus theta. That is cos 90 minus theta is sin theta, sin 90 minus theta is cos theta, cot 90 minus theta is tan theta, tan 90 minus theta is cot theta. So secant 90 minus theta is cosecant theta and cosecant 90 minus theta is secant theta. When we get 90 plus or minus, we have to change all these trigonometric ratios. So next it is, so if angle is 180 degree plus or minus theta or 360 degree plus or minus theta, trigonometric ratios remains the same. Suppose if we get tan of 180 plus theta, it will remain tan only, but we have to see whether it is plus or minus according to which quadrant they lie. So next it is, if angle is 90 plus or minus theta or 270 plus or minus theta, trigonometric ratios will change. So sin changes to cos, cos changes to sin, tan changes to cot, cot changes to tan, secant changes to cosecant, cosecant changes to secant. So that is if we get secant 270 plus theta. So we have tried secant 270 plus theta as cosecant theta. So it is secant 270 plus theta is cosecant theta. So since angle is 270 or it is 90, that is cos of 90 plus theta. So cos of 90 plus theta is sin theta, but you have to see the quadrant. So 90 plus theta is second quadrant. So cos is negative in second quadrant. So cos 90 plus theta is minus sin theta, and secant 270 plus theta is cosecant theta. So here 270 plus theta is fourth quadrant. So in fourth quadrant, cosecant theta is positive. So therefore we get secant 270 plus theta is cosecant theta, and cos of 90 plus theta is minus sin theta. So we know that plane is divided into 4 quadrants. Plane is divided into 4 quadrants. So first quadrant is in between 0 to 90 degree. So angle is more than 0 degree or it is less than 90 degree, or we can take it as 360 plus theta and 90 minus theta. Here we can take this angle as 360 plus theta or it is 90 minus theta. In first quadrant, all trigonometric ratios are positive. So in first quadrant, all trigonometric ratios are positive. And in second quadrant, so second quadrant angle is more than 90 degree and less than 180 degree. So here we write angle as 90 plus theta or 180 minus theta. When we get angle 90 plus theta or 180 minus theta, they lie in second quadrant, and in second quadrant only sin theta and cosecant theta are positive. So reciprocal of sin theta is cosecant theta. So therefore sin theta and cosecant theta are positive. In third quadrant angle is more than 180 degree and less than 270 degree. So it is 180 plus theta and 270 minus theta. If we get angle 180 plus theta or it is 270 minus theta, that angle lies in third quadrant. So in third quadrant, tan theta and cot theta positive. So tan theta is positive and its reciprocal cot theta is also positive. In third quadrant, tan theta is positive. And in fourth quadrant angle is more than 270 degree or less than 360 degree. Or we can take it as minus theta also. Minus theta means angle is in fourth quadrant. So here we can consider angle is 270 plus theta and 360 minus theta. So here cos theta and secant theta only positive. So in fourth quadrant, cos theta and secant theta are positive. So here we can write C, that is cos theta or secant theta is only positive. So we get ASTC, that is in first quadrant all are positive. In second quadrant only sin is positive. In third quadrant only tan is positive. And in fourth quadrant only cos is positive. So remember this ASTC rule, that is in first quadrant all are positive, second quadrant sin is positive, third quadrant tan is positive, and fourth quadrant cos is positive. So next we study some important formulas. So we studied sine of A plus B. So sine of A plus B is sin A cos B plus cos A sin B. So when it is sine, you have to take alternate sine and cos. So same type, sin A minus B. Sin A minus B is sin A cos B minus cos A sin B. For sin A plus B, so here also it is plus, and for sin A minus B, so here also it is minus. So for sine, we have to take alternate sine and cos. But for cos A plus B, so cos A plus B is cos A cos B minus sin A sin B. When it is plus here, you have to take minus. So same type, when it is minus, so cos A minus B is cos A cos B plus sin A sin B. So here both terms are in cos. So here both terms are in sin. So that is cos A plus B is cos A cos B minus sin A sin B, and cos A minus B is cos A cos B plus sin A sin B. So next formula is tan A plus B. So tan A plus B is tan A plus tan B divided by 1 minus tan A tan B, and tan A minus B is tan A minus tan B divided by 1 plus tan A tan B. So these are some important formulas. So next we see next formula, tan of pi by 4 plus theta. So we know that tan of A plus B is tan A plus tan B divided by 1 minus tan A tan B. But here first angle is pi by 4, and we know that tan of 45 degree. Tan of 45 degree is 1. So therefore we get tan of pi by 4 plus theta is 1 plus tan theta divided by 1 minus tan theta. Same type, we get tan of pi by 4 minus theta is 1 minus tan theta divided by 1 plus tan theta. So here we have to use formula tan of A minus B equal to tan A minus tan B divided by 1 plus tan A tan B, but tan pi by 4. So angle A is pi by 4. So tan pi by 4 is 1. So we get tan of pi by 4 minus theta is 1 minus tan theta divided by 1 plus tan theta. And next formula, cot of A plus B. And cot of A plus B is cot A cot B minus 1 divided by cot B plus cot A. So here we are using cot B first. Why? Because in cot A minus B we get cot A cot B plus 1 divided by cot B minus cot A. So here it is cot B minus cot A. So here cot B plus cot A. So therefore cot A plus B is cot A cot B minus 1 divided by cot B plus cot A. And cot A minus B is cot A cot B plus 1 divided by cot B minus cot A. And next formula, it is sin A plus B into sin A minus B equal to sine square A minus sine square B, or you can write it as cos square B minus cos square A. So we know that sine square theta can be written as 1 minus cos square theta. So therefore sine A plus B into sine A minus B equal to sine square A minus sine square B, and you can convert into cos. So it will be cos square B minus cos square A. So same type, cos A plus B into cos A minus B equal to cos square A minus sine square B, or it is equal to cos square B minus sine square A. So cos square A minus sine square B equal to cos square B minus sine square A. So next it is multiple angle formula. So sin 2A equal to 2 sin A cos A. So we have sin A plus B formula. So when we substitute B equal to A, we get sin 2A. So sin 2A is 2 sin A cos A, or it is also equal to 2 tan A divided by 1 plus tan square A. So it is sin 2A equal to 2 sin A cos A, or equal to 2 tan A divided by 1 plus tan square A. So next it is cos 2A. So cos 2A formula is cos square A minus sin square A, or it is equal to 2 cos square A minus 1, or it is equal to 1 minus 2 sin square A, or it is also equal to 1 minus tan square A divided by 1 plus tan square A. So in cos A plus B formula, if we substitute B equal to A, we get cos 2A equal to cos square A minus sin square A, and then we can convert sin square A to cos square A, or we can convert cos square A to sin square A. So we get all these formulas. So cos 2A is cos square A minus sin square A, or it is 2 cos square A minus 1, or it is 1 minus 2 sin square A, or it is 1 minus tan square A divided by 1 plus tan square A. So next it is tan 2A formula. So tan 2A is 2 tan A divided by 1 minus tan square A. So tan 2A is 2 tan A divided by 1 minus tan square A. In tan A plus B formula, substitute B equal to A. So we get tan 2A equal to 2 tan A divided by 1 minus tan square A. So next it is sin 3A. Sin 3A is 3 sin A minus 4 sin cube A, and cos 3A equal to 4 cos cube A minus 3 cos A. So sin 3A start with 3. So it is sin 3A equal to 3 sin A minus 4 sin cube A, and cos 3A start with 4. It is 4 cos cube A minus 3 cos A. In sin 3A we get all terms in sin only, and in cos 3A we get all terms in cos only. So it is sin 3A equal to 3 sin A minus 4 sin cube A, and cos 3A is 4 cos cube A minus 3 cos A. And next formula, it is tan 3A. So tan 3A is 3 tan A minus tan cube A divided by 1 minus 3 tan square A. So that is tan 3A is 3 tan A minus tan cube A divided by 1 minus 3 tan square A. And next formula, it is sin theta. So sin theta can be written as 2 sin theta by 2 cos theta by 2. So we have formula sin 2 theta. So sin 2 theta is 2 sin theta into cos theta. So we can divide all these angles by 2. So we get sin 2 theta by 2 equal to 2 sin theta by 2 cos theta by 2. So here 2 to get cancelled. So we get sin theta equal to 2 sin theta by 2 cos theta by 2. So this is half angle formula. So sin theta can be written as 2 sin theta by 2 cos theta by 2. And we can write cos theta, and cos theta can be written as cos square theta by 2 minus sin square theta by 2. If you want, we can factorize this. It is of the form a square minus b square, and we can write it as cos theta by 2 plus sin theta by 2 into cos theta by 2 minus sin theta by 2. So therefore cos theta can be written as cos square theta by 2 minus sin square theta by 2. And we have 1 plus cos theta. 1 plus cos theta equal to 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2. That is, we have cos 2 theta is 2 cos square theta minus 1. Using that, we get 1 plus cos 2 theta is 2 cos square theta, or we can write 1 plus cos theta is 2 cos square theta by 2. So same type, we get 1 minus cos 2 theta is 2 sin square theta. So therefore, we get 1 minus cos theta is 2 sin square theta by 2. So 1 plus cos theta is 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2. And next one is 1 plus sin theta. So we can write 1 as sin square theta plus cos square theta. Using half angle, we can write 1 as sin square theta by 2 plus cos square theta by 2. And sin theta can be written as 2 sin theta by 2 cos theta by 2. And it is of the form a square plus b square plus 2ab. So we can write it as sin theta by 2 plus cos theta by 2 whole square. So it is 1 plus sin theta is sin theta by 2 plus cos theta by 2 whole square. So same type, 1 minus sin theta. So 1 minus sin theta can be written as sin square theta by 2 plus cos square theta by 2. That is 1 can be written as sin square theta by 2 plus cos square theta by 2. and sin theta can be written as 2 sin theta by 2 cos theta by 2, and it is of the form a square plus b square minus 2ab. So and we can write it as sin theta by 2 minus cos theta by 2 whole square. So here which value is more? So that one we can write first, or we can write this as cos theta by 2 minus sin theta by 2 whole square also. That is cos theta by 2 minus sin theta by 2 whole square, or it is sin theta by 2 minus cos theta by 2 whole square. So next it is 1 minus cos theta by 1 plus cos theta. So we know that 1 minus cos theta is 2 sin square theta by 2 and 1 plus cos theta is 2 cos square theta by 2. Combining that we get 1 minus cos theta by 1 plus cos theta is tan square theta by 2. So same type we get 1 plus cos theta by 1 minus cos theta. 1 plus cos theta is 2 cos square theta by 2 and 1 minus cos theta is 2 sin square theta by 2. So combining that we get 1 plus cos theta by 1 minus cos theta is cot square theta by 2. So next it is transformation formulas. So it is 2 sin a cos b equal to sin of a plus b plus sin a minus b, and 2 cos a sin b is sin a plus b minus sin a minus b. That is 2 sin a cos b sin a plus b plus sin a minus b, and 2 cos a sin b sin a plus b minus sin a minus b. If we get sin and cos, so here it is addition. So if we get cos and sin, here it is subtraction of sin and sin. So next it is 2 cos a cos b. So here both numbers are in cos. So here also both numbers are in cos, and we have to add this. It is 2 cos a cos b is cos of a plus b plus cos a minus b, and 2 sin a sin b. So 2 sin a sin b is minus of cos a plus b minus of cos a minus b. We can multiply this minus inside, and we can write this as cos a minus b and minus cos a plus b. So it is 2 sin a sin b equal to minus of cos a plus b minus cos a minus b, or it is equal to cos of a minus b minus cos of a plus b. So next formula, it is sin c plus sin d is 2 sin c plus d by 2 and cos c minus d by 2, and sin c minus sin d is 2 cos c plus d by 2 and sin c minus d by 2. Now here when both are in sin and it is addition, so here we get 2 sin and cos. So here it's sin and cos when both are in sin and it is addition. So here both are in sin and it is subtraction. We get cos and then sin. So it is sin c minus sin d is 2 cos c plus d by 2 and sin c minus d by 2. And it is sin c plus sin d is 2 sin c plus d by 2 and cos c minus d by 2. And same type it is cos c plus cos d. So here both are in cos and here it is addition. So it is cos c plus cos d. So we get both are in cos only. So it is 2 cos c plus d by 2 and cos of c minus d by 2. And it is both are in cos, and if we get minus, it is cos c minus cos d. We get both are in sin, and it is important here it is minus. So it is cos c minus cos d is minus 2 sin c plus d by 2 and sin of c minus d by 2. So these are important transformation formulas. So it is sin c plus sin d, it is 2 sin c plus d by 2, cos c minus d by 2, sin c minus sin d is 2 cos c plus d by 2, sin c minus d by 2. And cos c plus cos d is 2 cos c plus d by 2 and cos c minus d by 2, and cos c minus cos d is minus 2 sin c plus d by 2 and sin c minus d by 2. So next it is general solution of trigonometric equations. Suppose you consider equation of the form sin theta equal to k. Suppose you consider sin theta equal to half, and we can write this as sine of 30 degrees. So that is sine of pi by 6. So here we can take alpha equal to pi by 6. So we can write sin theta equal to k equal to sin alpha, where alpha is some known angle. So then general solution is given by theta equal to n pi plus minus 1 to the power n into alpha, where n is an integer. So here sin theta equal to k equal to sin alpha. So then theta equal to n pi plus minus 1 to the power n into alpha. That is general solution for sin theta. Next it is general solution for cos theta. If cos theta equal to k equal to cos alpha, where alpha is one known angle, then we can write theta equal to 2n pi plus or minus alpha, where n belongs to z. So this is general solution for cos theta equal to k. That is theta equal to 2n pi plus or minus alpha. Same time, if tan theta equal to k equal to tan alpha, where alpha is one known angle, so then we can write theta equal to n pi plus alpha, where n belongs to z. So it is tan theta equal to k equal to tan alpha, where alpha is one known angle, then we can write theta equal to n pi plus alpha, where n belongs to z. If you want to find general solution of the form a cos theta plus b sin theta equal to c, so you have to divide this by root of a square plus b square. So then we can convert first number into sin theta or cos theta and second number into sin theta or cos theta. So then we can apply cos a cos b plus sin a sin b, or it is sin A cos B plus cos A sin B formula. To find general solution of the form A cos theta plus B sin theta equal to C, so we divide both sides by root of A square plus B square. So next we consider relation between sides and angles of a triangle. We know that in any triangle we have three angles. It is denoted by APC. Then we have A plus B plus C equal to 180 degree. That is angle sum property. And the side opposite to angle A, it is denoted by small a, and side opposite to angle B denoted by small b, and side opposite to angle C denoted by small c. And we have small a plus B plus C. That is A plus B plus C equal to 2s, which is called as perimeter of a triangle. So it is capital A plus B plus C means sum of angles. It is 180 degrees. So angle sum property, same type we have A plus B plus C, that is small a, small b, small c are three sides of a triangle equal to 2s, that is perimeter. So it is A plus B plus C equal to 2s, and s is called semi-perimeter. It is A plus B plus C divided by 2. So next we have relation between sides and angle of a triangle in different rules. So we have sine rule first. It is A by sine A equal to B by sine B equal to C by sine C. So here A, B, C are sides, and here capital A, capital B, capital C are angles. So this is relation between side and angle. So that is sine rule is A by sine A equal to B by sine B equal to C by sine C equal to 2r, where r is the circumradius of this triangle ABC. So this is sine rule. So next we have cosine rule. In cosine rule, we can write A square equal to B square plus C square minus 2BC into cos A. So here A is angle and all other ABC are sides. So it is A square equal to B square plus C square minus 2BC into cos A. So here we are finding A square. So here also we have to use angle A. So same type, if you are finding B square, you have to find angle B. And here you are finding C square. Here you have to use angle C. So that is B square can be written as C square plus A square minus 2CA into cos B, and C square equal to A square plus B square minus 2AB into cos C. So next we have projection rule. In projection rule, we can write A equal to B cos C plus C cos B. So these two are angles. So this is cos C and this is cos B. So here C and B are angles. So same type we can write B equal to C cos A plus A cos C, and C equal to A cos B plus B cos A. So this is projection rule. So it is A equal to B cos C plus C cos B. So here we can change A, B, C to get other formulas. So next it is sine A by 2. So sine A by 2 can be written as root of S minus B into S minus C divided by BC. And cos A by 2 can be written as root of S into S minus A divided by BC. So we can write half angles using this formula. So sine A by 2 is root of S minus B into S minus A divided by BC. And cos A by 2 is root of S into S minus A divided by BC. And tan A by 2 equal to root of S minus B into S minus A divided by S into S minus A. So here 2S equal to A plus B plus C, or it is S equal to A plus B plus C divided by 2. So it is 2S equal to perimeter and S equal to semi-perimeter. It is A plus B plus C divided by 2. So here 2S equal to A plus B plus C. So next it is Napier's formula. So we can write tan of A minus B by 2. So tan of A minus B by 2 equal to A minus B divided by A plus B into cot of C by 2. Here we are using angle A and B. Here we have to use side A and B. So here we are using angle A and B. So remaining angle is C. So therefore tan of A minus B by 2 equal to A minus B divided by A plus B into cot of C by 2. Same type we can interchange AB to BC and BC to CA. So that is we can write formula for tan of B minus C by 2 and tan of C minus A by 2. So here tan of A minus B by 2 equal to A minus B by A plus B into cot of C by 2. So this is Napier's formula. The next it is area of triangle. If you know all the sides, so we can use this formula. That is S equal to A plus B plus C divided by 2. So then we can write area of triangle equal to root of S into S minus A, S minus B, S minus C. That is when we know all the sides A, B, C. So we can use this formula to calculate area of triangle. Or else we can use half into AB into sine C. So here A and B are two sides and C is angle. That is when we know two sides and included angle, we can use this formula, that is half into AB into sine C, or we can write BC into sine A, or you can write CA into sine B. So it is half into AB into sine C, or it is also given by ABC divided by 4R. So where R is the circumradius. To find area of triangle, we can use these different formulas. So it is root of S into S minus A, S minus B, S minus C, or it is half AB sine C, or it is ABC divided by 4R. And we know that in any triangle we have a plus b plus c equal to 180 degree. In any triangle we have a plus b plus c equal to 180 degree. So therefore we can write a plus b equal to 180 minus c. Then if we apply sine on both sides, we get sine of a plus b, sine of 180 minus c, and sine of 180 minus c same as sine c. So therefore sine a plus b can be written as sine c, and cos of a plus b can be written as minus of cos c. That is cos of a plus b is cos of 180 minus c, and cos of 180 minus c is minus cos c. That is in second quadrant, cos is negative. So same type we can write sine of a plus b divided by 2 equal to cos c by 2, and cos of a plus b by 2 is sine of c by 2. When we divide this angle by 2, so we get divided by 2. Here we get 90 minus c by 2. So therefore sine of a plus b by 2 is sine of 90 minus c by 2, which is same as cos c by 2, and cos of a plus b by 2 is same as cos of 90 minus c by 2, which is same as sine c by 2. So therefore sine of a plus b by 2 is same as cos c by 2, and cos of a plus b by 2 is same as sine c by 2. This is possible in a triangle ABC. Since we have a plus b plus c equal to 180 degree, so we can write a plus b equal to 180 minus c, and a plus b by 2 equal to 90 minus c by 2. So using this relation, we can write sine a plus b is sine c, and cos a plus b is minus cos c, and sine a plus b by 2 is cos c by 2, and cos of a plus b by 2 is sine c by 2. That's all in this video. I will continue other chapter explanation in next video. Watch other chapter videos in my YouTube channel, Aakruthi Mathematics Classes. Thank you for watching. Please like, share and subscribe my YouTube channel for more video notification and support my channel. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.